Hey everybody, Mr. Quick here. Today we're going to be starting Module 5 of Eureka Math/Engage New York Math. We're going to be looking at Lesson 1 today, the area of parallelograms, basically looking at rectangle facts to help us find the area of parallelograms. So we're going to jump into some geometry. Module 4 was quite the long module, 34 lessons. Module 5 is much shorter, but there's a lot to it. So we're going to go ahead and jump right into it. Okay, for starters, let's name each shape. This is just a quick review. You should be noting that, hey, we've got two triangles here, but we want to be specific. If you'll notice, this has a 90-degree angle. That's what that little box means. So that is a right angle. So we have a right triangle here. These angles, if you'll notice, are all acute angles. They're all less than 90 degrees. So here we have an acute triangle. Let's put acute tri. Here you'll see that these two lines are parallel, meaning they can go on forever in that same direction and they'll never meet. And then the other two lines here are also parallel, and so they'll go on forever and never meet. So since that has two sets of parallel lines, we're going to call that a parallelogram. Okay. Now, this is a shape you've probably known since you were about a year and a half old, maybe. It's a rectangle, right? Rectangle. Now, if you're saying to yourself, well, wait a minute, these two lines would go on forever, so those are parallel lines, and these two lines would go on forever and never meet, and so those are parallel lines. Isn't that also a parallelogram? And the answer is yes, it is. However, it's a rectangle is a form of a parallelogram, but because it's specific, it has more specific rules, it's commonly called a rectangle because it just has a more specific name. Specific name, if I can speak here. And then here we have a quadrilateral, meaning it has four sides. But to be more specific, it has two lines right here, which are parallel. But the other two lines, if they kept going, eventually they would cross each other. So, if I can go back a hair so we can just see it a little bit better. This is a trapezoid. Okay, that was a brief review of some of these shapes we're going to be working with going forward here. So let's get into parallelograms. Lines are considered parallel, and you'd write that like that, right? Two parallel lines. When they basically go in the same direction, they go in both directions, I should say, and they would never meet. So if you extended these lines, you extended this line this way, this one this way, those two would never meet. Now, it's a parallelogram because these other two lines, if you extended those, they would also never meet. Now, this side and this side meet, but they're not parallel lines, right? So it has two sets of parallel lines. So we're going to look into how do we find the area of a parallelogram. Well, as you'll see here, they have split this off, so you have almost this little triangle here, right? You have a 90-degree angle here, and a 90-degree angle here. This dotted line is the height because it goes from the bottom of the base all the way to the top. And then the base is considered the entire bottom part, okay? Base. Those are important terms. Now, here's a little trick. If I took this triangle and I could cut it off and move it over here, I could place it right here, right? And so what that would mean is this section is gone. Okay, I tried to erase that the best I could. So now, if you look at it, it still has the same area, so the space inside, because we just took this part of the parallelogram, this little triangle, we cut it off and we moved it over here. But so the space inside isn't any different. It's just the space that was over here is now over here. But if you look, we've now made a different shape. We've made a rectangle. Now, if we were to measure this, and let's say this is 3 inches and then let's say this piece down here, the base, is 7 inches, and we wanted to find the area, we would do 7 times 3, right? So we'd have 21 inches squared. This is the area of this rectangle, and if we went back and put that triangle back where it started, then it is still the same area, 21 square inches, or 21 inches squared. Okay, it doesn't change just because you move a piece. You know, you can pick up, you have a pizza and you pick up all the pieces and you put them in a different order, but you still put them in the box, it's still going to fit the same. It's still the same amount of pizza. Okay, so here's kind of the important thing. To find the area of a parallelogram, area equals base times height, or more commonly, area equals BH, right? Base times height. So base being the length of the bottom part here, height would be this. So again, if this is 7 inches and this is 3 inches, then we would have 7 times 3 is 21 inches squared, because it is area. Okay, let's look at a couple of quick examples here. All right, we've got a parallelogram here. This is 5 inches, this is 6, this height is 4. Just because they've given us 3 numbers doesn't mean we need to use them all, right? Area equals base times height. The base is 6. The height is 4. This side, which is 5 centimeters, we don't need it. It doesn't matter. Not for this anyway. So we have 6 times 4 gives us 24 square centimeters, or 24 centimeters squared. All we need is base times height. Okay, let's look at this one. So we've got a parallelogram here, right? 2 sets of parallel lines. Now, they've drawn this dotted line because this is not actually a section. Like in the actual shape, it would look, I'm not the best artist, but it would look something like this. The dotted line is just showing you, hey, that's where you find the height from, right? So, get rid of those dots there. Our base is 25, right? Area equals base times height. Our height is 8, excuse me. This 10 doesn't matter right now. We don't need it, okay? 25 times 8 is 200. We're dealing in meters, and because it is area, 200 meters squared. The area of this parallelogram is 200 meters squared. Okay, let's look at this one. Again, we've got a base here of 12 feet. The height is 7 feet. 7 times 12 is 84. We're looking at feet and its area. So 84 feet squared, or 84 square feet. Okay, those are all pretty simple examples. I want to show you one that's just a little bit more complicated, although not too complicated. All right, here's our shape. This part here is our shape. Okay, so the dotted line just shows you where the rest of it could be, but that's not where it is. They're using that dotted line to show you the height, right? Now, if I give you all these measurements, I just want to break this down real quick. This is 7 centimeters. If you went all the way across to make this shape a triangle, then that's 7, and then this portion is 25. Okay. The height from, if you want to think about it as ground level to the very top, then is 30 centimeters. And this side here is 38 centimeters. All we need still is area equals base times height. The height is easy, 30 centimeters. So we have area equal, area equals, we'll say blank times 30, right? The base is the tricky part, and it's not really tricky, but I just want to point this out to you. The base is only the base of the shape. It's only that part here. This part doesn't exist. When it's that dotted line, that's just showing you where it would be. So we don't need to add these up or anything like that. Right now, we just need to use the base, which is 7 centimeters. So 7 times 3 is 21. We have 1 0 to bring over because of the place value. It would be 210 centimeters squared. So I just really wanted to point out that the base is only the part of the shape, not the dotted line that they've given you here. All right, that's all the time we have right now. Hope this has helped. Remember that area, base times height, when it is a parallelogram. We'll work on some more examples of these together, and we'll talk soon. Thanks for watching.